In this video, we'll learn what are trigonometric functions. We use a right-angled triangle to understand these trigonometric functions. That means one of the angles in the triangle will be a right angle. That means it will have a measure of 90 degrees. Now let the corners of this triangle be A, B and C. This side opposite to this right angle is the longest side of the triangle, and that is called as the hypotenuse. Now we have 6 trigonometric functions, and they are sine, written as S-I-N, cosine, written as cos, tangent, written as tan, cosecant, written as cosec, secant, written as sec, and cotangent, written as cot. Now, the hypotenuse for a triangle is already fixed as the longest side of the triangle. Also, it is the side in front of the right angle. Now, depending if we are using angle A or angle B, we decide the base and the height for that triangle. Let's say we are taking angle A. Then there are two sides attached to angle A. One of them is the hypotenuse and the other is the side AC. We leave the hypotenuse. The other side which is attached to angle A will be called as the base. And the side in front of angle A, that means opposite to angle A, which is not attached to this angle, that means the side BC will be called as the height. On the other hand, if we were taking angle B, then the side attached to this angle, that means the side BC, will be called as the base, and the side in front of this angle, that means opposite to that angle, side AC, will be called as the height. That means the rule is the hypotenuse for a right angle triangle is always fixed as the longest side or the side in front of the right angle. The next thing is, for a particular angle, the other side which is attached to that angle is the base, and the side which is opposite to that angle, that is called as the height. Now for this video, we are considering angle A. So we calculate the trigonometric functions, all of them, sine, cosine, tangent, all of them for angle A. If we take angle A, that means side BC will be the height and side AC will be the base. So let's see the first trigonometric function, sine of A. The formula is sine of A is equal to height upon hypotenuse. That means sine of A will be equal to height is BC for angle A and hypotenuse is AB. So sine A will be equal to BC over AB. Now let's see the second trigonometric function, cos of A, and that is equal to base over hypotenuse. For angle A, the base is AC and the hypotenuse is AB. That means cos of A will be equal to AC over AB. The third trigonometric function is tangent. That means tan of A, and the formula is height over base. That means tan of A will be equal to, the height is BC and the base is AC. So tan A will be equal to BC over AC. The fourth trigonometric function is cosec A, and cosec A is hypotenuse upon height. Again, following the same notations, cosec A will be equal to hypotenuse, which is AB, and height, which is BC. So AB over BC. The fifth trigonometric function is sec of A, and sec of A is defined as hypotenuse over base. So sec A will be AB over AC. And the last trigonometric function is cot of A. Cot A is defined as base over height. So cot A will be equal to AC over BC. Now there are a few things to remember. Cosec A is 1 over sine A. Sec A is 1 over cos A. And cot A is 1 over tan A. That means sine A and cosec A are reciprocals of each other. Similarly, cos A and sec A and tan A and cot A, they are all reciprocals of each other. So you don't have to remember all the 6 trigonometric formulae. What you can do is just remember only 3 of them, and then you can invert them to find the remaining 3. Let's see what values these trigonometric functions can take. Since sine A is defined as height over hypotenuse, and I already mentioned that hypotenuse is the longest side of the triangle. That means height will always be less than hypotenuse. That means that sine A will always be less than 1. The magnitude of sine will always be less than 1. Similarly, cos of A, it is defined as base over hypotenuse. Again, the base will always be less than the hypotenuse. So, cos of A will also be like sine of A, always within the magnitude of 1. Now, for cosec A, it is defined as hypotenuse over height. And since hypotenuse will always be greater than height, that means cosec of A will always be greater than 1. So the magnitude of cosec A is always greater than equal to 1. Similarly, for sec of A, the hypotenuse will always be greater than base. So sec will also follow the same pattern as cosec, and sec A will always be greater than 1. Now tan A and cot A can take any real value, because tan and cot, they are actually ratios of the height and base, and there is no such rule as to height can be bigger or base can be bigger all the time. That is why they can take all the real values from negative infinity to positive infinity. One more thing to note is, since these trigonometric functions are actually ratios of the different sides of a triangle, be it base or height over hypotenuse or hypotenuse over base, since these are all ratios, that is why they are also called as trigonometric ratios. This is it for this video. We'll see more of these in the next videos. Bye bye.